All right, guys. So there's some questions in chapter 5. Is it 5? 4. 4 2, yeah. So there's a question where it's like a lottery problem. And let's say that the top prize, as I talk about this, I feel like I've done it already, but if I've done it already, oh well. So the top prize is $1,000, and then let's say the only other prize is $50, right? And let's say that they sell 100 tickets, and let's say that let's see, let's say that there are there's one top prize winner ticket, and there's 4 other prize tickets. So there's one way to get $1,000, and there's 4 ways to get 50. All right. So what you're going to want to do to figure out the expected value to see if you should play. Now let's say, one thing missing. Sorry. Each ticket costs it's $1,000 prize. Let's make it $15. Just make it interesting. I like it. All right. Now I'm going to pause. Okay. Just want to have my calculator handy for later. So if you make a table, x p of x table, because that's how we figure out expected value, is to set this up and figure out x times p of x. That's going to be the mean, which is another name for expected value. My x is going to be the money I can win. I can win $1,000, but minus 15. So I could win $985. I could win 50 minus 15, $35. Or if I don't win, and unfortunately, there's a lot of ways to not win, I'm out my $15. So what's the probability I win the top prize? Is 1 ticket out of 100. So this is a 1% chance, so 0.01. Let's probably get the other prize, 4 out of 100. So it's going to be 0.04. So that's 5% right there. So what's the probability I don't win anything? 95%. Now, what I can do, see if I can do this, is I can put this information here. Get over there. Stop it. Get out of my way. All right, so let's put this information here. I got 985, 35, negative 15. I got 0.01, 0.04, 0.95. Then I can make L2, L1 times L3. Oh, I'm so silly. L1 times L2. That's good, Jeff. So, I don't know why I did it all in the calculator. Just to remind you guys that you can if you want to. Right, so I'm going to copy those down real quick. I got 9.85. I've got 1.4, and I've got 0.1425. And if I add those up, and it's negative. My mistake, I didn't put a negative in there. Did I put a 0.15? Am I remarkably silly? I did. Instead of a negative, I put point. So sorry, guys. Negative 15. So that last number is going to be incorrect. This is awesome. On the fly. Yeah, negative 14.25. That makes more sense. Negative 14.25. So if I add all this up, it's my expected value. Now, for a lottery, your expected value should be negative because the people running the lottery want to make money. So if your expected value is negative, that means that that money is going to them. Their expected value is positive. So a negative expected value just means money is flowing away from you. In this case, it's money, right? which means whoever you are dealing with has a positive expected value. Sure enough, there's a -3 expected value. So for every person that plays this game, they expect to average making $3, even though they're paying out $1,000. This is how most lotteries are set up. Of course, the whole purpose for running a lottery is for the person running the lottery to make money. Sure, they're paying somebody some money, but it's a 1% chance they got to pay that much. 95% chance that they're getting this much. So overall, for every person that plays, they expect to make $3. So if they sell all the 100 tickets, they are going to make $300. End of story. So that one's kind of nifty. I don't remember which one that's like, there's a problem where it's a $500 top prize and so forth. Oh, no. And there's another problem exactly like this with rolling dice. But that's easy. It's going to be, the probabilities are going to be out of 6. So you're going to have money amounts here. The probability you get the appropriate numbers here. So it's going to be something out of 6, something out of 6, something out of 6. And then you just multiply, add. Not too bad. This is how you also do how to set insurance premiums. Anybody have car insurance? What they'll do for whatever your age is, they'll figure out how much money they could pay out, the probabilities of those payouts, and then they'll add up these to figure out their expected value, and they'll set the premium higher than this so that overall they are certain to make money. And once you hit 25, these probabilities change, and suddenly you pay lower premiums because everybody learns how to drive when they wake up being 25. It's amazing. Okay, that's enough for now. I think there was something else, but I got another meeting starting soon, so I think that's it. I'll post this up. See you guys.